So we've taken a look at exponentials, and in particular, what their graphs look like. Now we're going to turn our attention to solving exponential equations. So we're about to do these laws of exponents, but I want to show you where we're going. So what example 4 is going to look like. You are going to be solving equations. So you're going to have equal signs, and your x, or your variable, is going to be in the exponent. That makes this an exponential equation. Okay, so we're going to talk about how you would solve something like this. We have a whole bunch of them to do. Okay, and before we start these, we are going to go and reference these laws of exponents. Okay, these are some properties that you should have learned probably in high school. It may have been a while since you've seen some of them, but these will definitely help out when we're solving the exponential equation. So let's take a look at these first, and then we'll get into how you solve an exponential equation. Okay, there's 6 properties. The first row, we've actually done all 3 of these in the last couple of sections, so we'll kind of breeze through those. So it says, let S, T, A, and B be real numbers. A and B are assumed to be positive, so they're just positive numbers. So this first one is saying if you have 1 to the S power, so that's basically saying what is 1 to any power, okay? Because S is just a number. So if I go out to the side, you think about it, 1 to the first power is 1. 1 squared is 1 times 1, it's 1. 1 cubed, 1 times 1 times 1 is 1. Okay, even if you did 0, 1 to the 0 power is going to be 1. Even a negative power, that just means 1 over the something, change the sign. You're still going to get 1. 1 to any power is 1. Okay, all right, let me jump to this one. Okay, A is just some number. Anything to the 0 power is 1. So we've seen that already. All right. So the one in the middle, the property in the middle, A to the negative S. A and S are just numbers. So basically what this property is saying, how do we get rid of a negative exponent? And I've shown you that before. You're going to do 1 over the something, and you're going to change the sign of the something. So it's going to be 1 over A to the S. Okay. I'll give you a specific example of this again. Okay. So an example of this one, if you saw, I don't know, 8 to the negative 5. Okay. So 8 raised to the negative 5th power. Okay. This would be 1 over 8 to the negative 5. Change the sign of the exponent. So it would be 1 over 8 to the 5th. You could leave it like that, or you could put it into a calculator and see what 8 to the 5th is. All right, it would be 1 over 32,768. Okay, so you've seen how this property works. Okay, all right, the last 3 properties we haven't talked about much, but again, this is something you should have learned in high school. This should be a refresher for you. Out of these 3 in the bottom row, these 2 are going to be very critical. You have to know these, okay? And you have to know the difference between the 2 because they do look similar, okay? This is saying, I'm going to go ahead and give you an example first, okay? This is saying, notice that A is the base here, and then S and T are the exponents here. This is saying if you have the same base. So it's like having 2 to the 3rd power times 2 to the 4th power. So you've got the same base, and your exponents are not necessarily the same, okay? How do you combine these, okay, into 1 power of 2? That's the question, okay? So if you remember, you either add or multiply. The question is, which situation is which? Do I add the exponents or do I multiply, okay? If you should try to memorize this, but if you cannot remember, you can always write it out. This first guy is 2 to the 3rd power. That means 2 times 2 times 2. And then you're multiplying that by 2 to the 4th. So that just means 2 times itself 4 times. Oops, I'm writing the wrong thing down. I'm writing a 4. So 2 times itself 4 times. So we've got 2 times itself 3 times, 2 times itself 4 times. And so then you end up multiplying 2 by itself 7 times. So this is going to be 2 to the 7th. Okay, so you add the exponents in this situation. So this would be same base, add the exponents. Okay, you're combining this guy into one power of the base. Okay, here's the other situation, okay, where you're taking a power and raising it to a new power. Okay, so this would be like having 2 to the 3rd power raised to the 4th power. Okay, so this would be the situation where you're going to multiply the exponents. Okay, because if you had 2 cubed here, that's 2 cubed, and then you're multiplying it by itself 4 times, you end up with 2 times itself 12 times. Okay, so this would be the situation where you multiply the exponents. Okay, so how can you keep them straight? Well, if you've got a power of something times the same, well, a power of something times a power of the same something, okay, you're going to add. Okay, the best way to remember it is if the exponents are side by side, that's when you multiply. Okay, so here the exponents are side by side, that's when you multiply. Here the exponents are not side by side. You've got this 2 in the middle of them. Okay, but if the exponents are side by side, you want to multiply the exponents. If the exponents are not side by side, that's when you want to add. But remember, and to combine this one into, the same base, both of these have to be the same base. Okay, if I had something over here like, if I had 2 to the 3rd times 4 squared, I cannot combine these because this is base 2 and this is base 4. In order to combine them into one power of the base, they have to be the same base. Okay, so make sure you understand the difference between these two situations. Okay, this last property you may use once in a while. Like I said, these two are the most critical. Okay, this is saying if you have inside parentheses something times something else, and then that whole quantity is raised to a power, you are also allowed to take what's inside and raise each quantity to that power and then multiply. So this would be a to the s power times b to the s power. Okay, so if I had, 2 times 3 raised to the 4th power, this could be the same thing as 2 to the 4th times 3 to the 4th. Okay, again, I don't know how helpful this property is, because if it were me, I would do 6 to the 4th. But this is allowed. You may have to use this, especially if you just have variables involved. So you are allowed to do this. So just keep this in mind. But again, probably for solving exponential equations, these three are going to be the most helpful. Okay. All right. So now that we have those properties in mind, we're going to start our journey of trying to solve exponential equations. Okay. Again, an exponential equation is going to be a statement where you have an equal sign and your variable is going to be in the exponent. Okay, so it's going to be a little different than something you've seen before. Okay, there's no quadratic formula. It doesn't help to just move things to one side. It doesn't work that way. This is a totally different ball game. Okay, so here's a statement about what we're going to do. And actually, there's going to be 2 types of exponential equations we're going to work with. In this section, you're going to learn one method that works for only certain types of exponential equations. Okay, and then in section 6.6, you will solve exponential equations using logarithms. Okay, we cannot do those yet because we need to spend the next couple of sections learning logarithms. Okay, so we'll come back. We're going to learn the simpler exponential equations, how to solve those, and then we'll be back to solve more complex ones once we learn logarithms. Okay, I'm going to come back to this statement in just a second. So let me just show you some easy exponential equations. Okay, and then the box will make more sense. Okay, so here's the first guy. Okay, it says solve each equation. Okay, so in this first one, here's our statement. This is an exponential equation. The x is in the power. 5 to the x power is equal to 5 to the negative 6 power. You want to know what value or values of x make this a true statement. So what you should notice is on both sides of the equal sign, I have the same base. I have 5 to a power. Since the bases are the same, the only way this can be a true statement is if the exponents are equal. Okay, so let me repeat that because that's the whole idea of doing these. Okay, on both sides, I have the same base. Remember, the base is the number that's being raised to the power. On the left side, I have base 5, and on the right side, I have base 5. Okay, so since these two quantities are equal, since the bases are the same, the only way they can be equal is if the exponents are equal. So since the bases are the same, we're going to set the exponents equal to each other. Okay, and that's what the value of x needs to be to make both sides the same. Okay, this was the easiest possible exponential equation that you'd ever get. Okay, they do get harder. Okay, but that is the whole idea. So let me go back to the box that was on the last page. Okay, so it is saying if you have an exponential equation that looks like this, okay, it says when two exponential expressions with the same base are equal, then their exponents have to be equal. Okay, so if you had the statement that a to the u power is equal to a to the v power, since the bases are both a, then that means the exponents have to equal. So u has to equal b. Sorry, u has to equal v. Okay, so that is how you're going to do these. You want to make sure the two sides have the same base. Okay, and when you're given the problem, it may not be that way, but you're going to figure out, can I manipulate one or both of the sides using these properties to make them have the same base? And then once they do have the same base, you want to go ahead and equate the exponents. Okay, so let's take a look at part B. Okay, so this is definitely one where the bases are not the same on both sides. Okay, again, when I look at this, this is an exponential equation. I have the x in the power. The left side is base 3. The right side is base 1, because you can think of this as 81 to the first power. Okay, so the bases are not the same. Okay, it would be great if I could make them have the same base. Okay, so we need to change one of the sides. Okay, it is usually, not always, it is usually easiest to change the bigger number into the smaller number. So I am going to use, or I'm going to leave the left side alone, and then I'm going to rewrite 81 as a power of 3. Okay, so what power, 3 to what power gives me 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So that means 3 to the 4th is equal to 81. Okay, so 81, what's on the right side of the equation, is the same. 81 can also be written as 3 to the 4th. Now on the left side, I have a base of 3, and on the right side, I also have a base of 3, and these two sides have to be equal. Okay, so since the bases are the same, I can go ahead and equate the exponents. So I get negative x is equal to 4. Okay, and now I want to solve for x because that has been my ultimate goal. All right, so I'm going to divide both sides by -1. Whatever you do to one side, you do to the other. Okay, and you get x is equal to 4. Okay, you can, the great thing about any equation, whether it's exponential or not, is you can check yourself. Okay, once you get your solution, plug it back into the original equation and see if you get a true statement. Okay, you can check this. Okay, so take x equals 4, that's your solution. So let's type it into the left side. We have 3 raised to the negative is already there. Okay, and then x is 4. And then, oops, hold on. I messed up. This should be -4. See, I don't have you guys in person to yell at me. Okay. All right, so if I came back over here, remember, 4 divided by -1 is -4, not +4. So now let's go check ourselves. So we're going to have 3 raised to the, this negative is already there, and then x is -4, okay, and you'll get 81. So the x value that makes both sides true is -4.